In this video we are going to express the volume again of a solid that is generated by rotating a region around a line that could be y equals c or x equals c that don't be the coordinate axis. These problems are one different from the others, so are new ones. Others change a little bit, others are the same. The issue here is that we are going to find the volume expressed but without graphing. That would be a little more difficult. I always want to do it without graph, not because the graph are not important. The graph is very important and it's easier to do it if we know the graph. But if we don't have anything to graph or we don't know how to graph, we need to know how to do it without the graph. So this time I will not put graphs for the new problem, and we will see that for the problems that are the same, we have the same answer that we got in the previous video. Alright, so find or express the volume as a defined integral for the solid that is generated by rotating the region R that is enclosed by x equals 4, the x-axis, y equals square root of x. We will rotate this around x equals 4, the region enclosed by y equals 4, y-axis, y equals square x, rotating it around y equals 4. The region enclosed by x equals 1, y equals 2, y equals 4, rotating it about x equals 1. The region enclosed by y equals 3, x equals 2 pi over 2, y equals 3 cosine x, rotating it about y equals 3. This was one of the problems that we did in the previous video. Y equals 1, y equals cube x, the y-axis, the region enclosed by this, and about the y equals 1, rotating it around y equals 1. The region enclosed by x equals 3, y equals 2, y equals 1 over x minus 1, rotating it about x equals 3. The region enclosed by y equals 2, y equals 2 times x minus 1 square, rotating it about y equals 2. The region enclosed by y equals 1, x equals 4, y equals square root of x plus 1, rotating it about y equals 1. The region enclosed by y equals square root of x plus 2, x equals minus 2. This doesn't look very nice. Minus 2, y equals 1, y equals 3, about x equals minus 2. The region enclosed by x equals 4, y equals e to the x, y equals 1, rotating it about x equals minus 4. The region enclosed by x equals minus 1, x equals minus 1, sorry, y equals minus 1, x equals 2, y equals x square x minus 1, rotating it about y equals minus 1. And the region enclosed by y equals sine x, the x-axis, and the left of the line x equals pi over 2, and this will be rotating it around or about x equals pi over 2. If you think you can find it, stop the video now and the next continue to see we have the same result, or stop the video in any time you wish. Alright, so first, we already saw in the previous video how to do it with the graph. So first we need to find if we're rotating the region around x equals c or y equals c, because that will define the defined integral will be with boundaries of y or of x, and the integral would be set as y as a function of x or x as a function of y, or if we're integrating in dy or with respect to dy or with respect to dx. Here we are rotating it around x equals 4. So that means that our circles or discs are going to be, this will be x equals 4, the circles or the discs will be something like this. We have x equals 4, the x-axis, and y equals square root of x. Alright, so the boundaries would be the boundaries. This time we will have the integral from the x-axis is the same as y equals 0. Because we have a rotating it around x equals 4, we need to put everything in terms of y, the y, and the boundaries are in y. So we go, one of the boundaries is 0, and let's see what's the other. The other will be when y equals square root of x is equal to 4. So y would be equals to plus or minus 2. Because we are enclosing it around the x-axis, that is y equals 0, that is already a bound. The other bound would be, in this case, would be y equals 2. So this goes from y equals 0 to y equals 2. Because that's one of the boundaries, and let's put y equals square root of x in terms of y. So x would be square y. X is square y. So the function would be, remember, we are not rotating it around the line x equals 0. We are rotating it around x equals 4. So now I'm just saying the algorithm because the method of how doing it we already see it in the previous video with graphs, etc. So here I'm just saying the methods without graphing. So we will pick a value of y between the boundaries, that is between 0 and 2. We will substitute that into our function, that is x equals square y, and we will see which function is larger, this or the one at which we are rotating it. Wherever the greater be, from that we are going to subtract the other one. So let's pick 1. So x equals 1 when y is equals to 1, and when y is equals to 1, whatever, x always is going to be 4. So from this we're going to subtract this. So our radius is 4 minus square y. Remember the area, the volume is the area, that is pi r squared times the x or the y, whatever. In this case is the y. So this square times pi, I can take out of the integral dy. Alright. In the next video, if you wish, we will continue with the other